So this is our project for Microprocessors Lab, the LED touch controller. Our high-level objective is basically to activate LEDs placed on a breadboard using the capacitive slider of the Freedom board. We achieve this by soldering wires to the GPIO outputs of the board and then configuring them through code to output high when certain positions of the slider register a touch. We also included an external push button placed on the breadboard. That's also configured through GPIO, and that's to enable brightness control instead. While the button is pressed, the capacitive slider allows us to control brightness of all of the LEDs simultaneously. Naturally, when no contact is made with the slider at all the LEDs are off by default. A quick rundown of the materials used for our project. We use the Freedom board as our controller for the LEDs. Of course, we have the LEDs themselves, 4 of them exactly, 1 red, 2 yellow, 1 green. 1 push button to activate all of the LEDs, and then also to change the function to brightness control, and of course the breadboard itself, including all the necessary wiring. And now here's exactly how the Freedom board is controlling the LEDs. The code is spread over 3 columns, so we can look at it starting from the top left, progressing to the bottom right. The header files in the beginning are mandatory for getting functionality out of the slider. The push button is configured as a digital input. Setting each of the LEDs corresponding to a GPIO output to PWM allows us to easily control brightness. The float value B is set by default to 0.99 to avoid all the LEDs constantly being off, say if the value were 1 instead. Everything is encompassed within if and else statements pretty much. To start things off in the first column, we see that the slider is untouched. When it's untouched, it perpetually waits for user input. The else-if statements that follow are what enable brightness control. We see the term key, and that's basically telling us what part of the slider we're making contact with. Looking in the middle column, the lines L1 equal B, L2 equal B, and so on, turns on all the LEDs while brightness is being adjusted. Following that, a collection of else-if statements are responsible for the default function of the slider, and that's again to turn on different LEDs when different positions of the slider are touched. Since we wanted only 1 LED to correspond to each discrete range of the slider, all the other LEDs are configured to be off while 1 of them is on. And finally, here's our controller in action. Like we talked about earlier, a set range of the slider corresponds to an LED, much like a button does. By touching each position of the slider, we see that the LED activates as expected. This can even carry over to a sliding motion, and we see that the LEDs transition on and off pretty seamlessly. Once the button is pressed, however, we can start controlling brightness. We see that the function of the slider has been completely replaced with brightness control, which is pretty evident here as all of the LEDs are turned on while brightness is being adjusted. When the button is released, we see that the original functionality of the slider is restored. And that basically does it for our project. Have a wonderful day.